So here is something called paired recordings. My background in sensory system physiology used a lot of this kind of work, a lot of neuroscience type of work, a lot of other areas in cellular level. So like working with a cell in some part of the body does this kind of work. And occasionally you get it in like larger, like a system level, like an organ system, or you get it in a whole animal level, which is you test something before you do a treatment, you do the treatment, and then you test after. That has rarely been done on short time scales in anything approaching biosignals and a whole person level. Most of the time, the papers I've read, including all of the heart rate variability and a lot of the heart rate training literature, is we measured before your training, we measured at the end, maybe it's like a training camp, you had like a month, maybe it's a 3-month cycle for something, maybe it's like a cardiovascular program for people who have cardiovascular disease and they're going to check them after like 3 months. It's a long period of time, no matter what it is. And it's like, we checked before, we checked after, and there's a difference. Okay, that's really hard to believe that something like this was the cause for 2 reasons. One, obviously lots of things can change over long periods of time. So another reason why paired recordings are chosen is because you can hopefully rule out a lot of other system processes that could happen in that short period of time. Because a lot of things take longer, right? Like if you want to build muscle, for example, it takes more than 30 seconds, sadly. If you want to, be able to run really fast and you go out and do it one time, you didn't really change your running time. If you want to run the New York Marathon, you can't just train once. You see where I'm going with this? So in this case, I'm going to bring you back to the time constant. I mentioned that the time constants were determined from looking at these power spectra in the frequency domain. But the basic idea was, whether it's one of the nerves impacting your heart, nerve types, or the other one, they take place in less than 30 seconds. The time constant, by the way, just to be a little bit more detailed, is how long for basically almost a third decrease in something happening. So if you get a big spike in something and it starts to come down, when it gets down to about a third, that's the number that becomes the time constant. It's about a third. So, you could times this out for longer and still say like there's pretty much, no change after about 3 times these numbers. So after, call it 3 times 30 seconds. So after 90 seconds, you would show no change in whatever it is that was going on with heart rate variability based upon the work that was done with dogs. So it's a short-term process. It's not super short, right? It's not like, less than a couple seconds, but it is pretty fast. So how do you then say, there's a yellow flag I want you to think about, because this is a great one for thought process for future work. And I'll put it in a different context first. A lot of people out there have probably tried to improve something about your physical fitness, health, and wellness. Whether it's go to a gym, whether it's stretch and work on your flexibility, whether it's decide to go outside and maybe run, or bike, or row on the water, whatever it is, at some point in time, if you're watching this, you have probably tried to do something along those lines. And every single one of the things that you want to improve takes longer than a day, is that right? 24 hours times 60 minutes times 60 seconds. That is far longer than these numbers. So, no one would believe that if I said, come on into the gym, you give me 1 hour of your life and I'll help you drop 5 pounds. Because it doesn't work. How about we're going to put on 2 pounds of muscle? Doesn't work. But if you kind of consistently do work, then maybe in the future you have lost 5 pounds, or you've gained 2 pounds of muscle, or you've taken 30 seconds off your mile time, or you've reduced your stress, maybe you sleep better, whatever it is you want to measure. But it rarely happens really fast. And that's because the time constant for those things, for the whole thing to happen, that is pretty long. It takes a long time. The time constant is long. But you did a shorter thing. Maybe you worked out for 20 minutes. Maybe you did a breathing practice. Maybe you did cold therapy. Maybe you took a foam roller. I got a foam roller over here. I'm going to introduce this guy. Maybe you did that for 5 minutes. And over time, you saw an improvement in something. So that implies is that you do something now, and that something changes something else, and that takes a while to work through. And then you do it again, and that helps continue the change. So for future work, I want to make a plug for these paired recordings, because if supposedly you can improve something like heart rate variability, and if I cared about this for myself, which I do, and for a lot of clients, I do for them as well if they care about it. I want your abilities to be good 3 months from now, because maybe that's when your season starts, right? I want you to recover from a really tough season relatively fast so that you can go and have awesome vacations. Go hang out with your family, or go party in St. Tropez with Erling Haaland, whatever it is. So, whether I want you to get someplace in 3 months where you're really good, or whether I want you to wipe away the bad stuff, which is, I'll do a lot of this, bad stuff relatively fast, then we need to find something and deal with these time constants and deal with repetition and consistency in order to have it happen. So knowing what type of thing might affect this by itself in a short time period might give an insight into something that's like, well, if I keep doing that thing a certain amount of times, that might make sense. You take a guess, right? We do that. We guess, we try. Then we can see if, again, over 3 months or in 2 weeks, did we get a change we wanted to see? Okay. What about adding? So again, that's one idea. And of course, measuring later in time, right? If you think something's going to matter now, one classic thing is DOMS, right? So if you've ever had soreness from working out, the next day or 2 days later, that's delayed onset muscle soreness. Delayed meaning it took a while. You might have a delayed version of something that's important for actually increasing your heart's ability to function and respond to both the strenuous stuff like exercise, but also coming down and braking and accelerating, getting back to a nice, comfortable rest place that you can sleep and do everything else you want to do. The idea there is maybe we need to check at different points in time, and this has been done a couple times in this type of world where they check a little bit after something like, say, 3-4 hours. Because as in the person whose heart rate is coming down, they might have been interested in, I give you sprints, right afterwards your heart rate is still elevated. So we'll check it right then where it's coming down, and then we'll check it, say, 4 hours later and maybe 8 hours later. So there is a benefit to doing that as well. It's extremely rare in the literature, like I said. It's very uncommonly done. I don't think I've ever seen it done with heart rate variability. It's been done at least a few times with heart rate training, again, trying to figure out that metabolism. So that's time to add something like that back into the mix too. Okay, I want to introduce one last thing, which is the coefficient of variation. So the coefficient of variation, just real fast, I'll verbally explain it. It tries to deal with the fact that people or situations have different means. So I drew a sigma over a mu, that is standard deviation over the mean. The idea there is if you, for example, if you knew that your mean mile time was 7 minutes, and you did a workout program and you got a great time, it was awesome, and you took your mile time down to 6.30, 6:30. So you took 30 seconds off your mile time. Fantastic. Somebody else comes along, old like me maybe. Maybe they came off of surgery like I did, and it's like, ooh, 10-minute mile might be pushing it right now, 3 months after surgery. But let's just take that as a baseline and let's ease into it. And I go from a 10-minute mile down to, let's say, a 9-minute mile. That relative change might be equivalent. An alternative way to think about this is if you have a group of people, you have a team, or you have like a military cohort. I've seen this study done with heart rate variability. You take a whole bunch of people and you average out something like, let's say, their heart rate variability numbers. Let's say it's 40, like I still have up here. And then you have another group, let's say, or the same group that comes back from being overseas, and you measure their heart rate variability, and it's 48 milliseconds. Now, what is the change that might happen there? What is the variation that might happen there amongst all the people? If you start off with it's 48 plus or minus 48, first situation, when they come back, maybe it's 48 plus or minus 2. You had a big range at the beginning, you had a small range at the end. that coefficient of variation number, because it'd be the variation divided by the mean, the small one would be small, and the big one would be big. And that would tell you that there's a difference there. And it also helps you with the fact that, like, maybe one group, one team you work with, is a certain height, or one thing you care about is a certain average. And so you need to be able to compare that to something or someone who's different. So the idea of a coefficient of variation there is meant to help deal with some of these problems that we're talking about, where you have, for example, maybe a different average heart rate. Now that would deal maybe with this situation where you're looking at like two people sitting around doing nothing. But the problem with that number in this situation is it doesn't take into account that the actual number itself is still dependent on the number itself. So this becomes one way to start looking at alternative measurements that might be useful in combination with other things that we're measuring here for variation, for looking at like how does a recovery program work for this person, how does a balance program work for this person. It helps us give another option that's a little bit different, and it's also helps look at people who already are different and put them a little bit into a similar scale. And the teaser part of this is that I have been doing this for a while. I've been putting different type of statistical measurements that come from the same stuff, whether it's average, whether it's mean, whether it's standard deviation, whatever it is. I've been putting these things together in different ways and try to import them into machine learning programs to see if having a little bit broader view of the numbers, the machine essentially then can have something that's a little bit more like evaluating a more complex curve that happens because maybe that person happens to have a little bit of a weird variation that day, or they had just freaked out a little bit about, oh no, I got to get to work, and so their heart rate was going up a little bit. Or maybe they were feeling great because they got a great piece of news, got a new job, and their heart rate was coming down a little bit. And so there's ways to sort of like try and put more information into essentially a fast calculator. Machine learning is really fast calculators in fancy ways, really fancy ways sometimes. And out of it then you might get something that's more complex that helps you deal with a more complex person. And if you track that over time, maybe you'll see some real changes. So I'm going to leave it there.